Here we go. Welcome to Desk of Ladyada.
Hey everybody, and welcome to the Desk of Ladyada. It's me, Ladyada. With me, Mr. Ladyada on camera control. We got a couple minutes from my desk, all the engineering I'm up to this week. But first up, some news, Mr. Ladyada. What's going on?
Yeah, let's hop over to your computer.
Okay.
So if you go to adafruit.com.
Adafruit.tumblr.com.
Yeah, you can go to adafruit.com/blog. You can also go to adafruit.tumblr.com or tumblr.com/Adafruit. You can see the full month of March and Touch things that we're doing. So every day there's retro Mac related things, and folks really like it. Lots of nostalgia. If you've never heard about it, that's okay too. This is a good chance to learn about a lot of computing past and how we got here.
Yeah.
We're posting up photos of our collection of things. I'm not going to show all the photos, but what I will show is a little bit of a preview of some of the things. And then we also have accessories and things that are kind of in the Mac orbit.
Yeah.
So we have a 25th anniversary Mac. These are beautiful with a big giant Bose speaker and these really weird cables.
So weird.
Yeah, I'm also like making a computer for our daughter, and here's a very neat Crayola.
Hey, it's an ortho keyboard.
Yeah, yeah, and this is plugging into a Mac. I'll talk about that probably in a future show. And then we spent a lot of time on HyperCard because it really is one of the reasons I'm here. And you have some experience with HyperCard. What did you do back in the day?
I loved making games with HyperCard. I loved programming with HyperCard. So kind of my first programming language. And so like you get the demo version and you do like, it was like the Control-Shift-M or OpenAppleM, and then you type like magic and it would like turn it into like the full set. So that was super cool. And then I just loved making cards, and I remember just making a lot of like point and click games because that was like cool at the time. And it was it's funny, like nowadays people are always like, oh, we should make it easy for people to like write games, but like I was in grade school and doing stuff with HyperCard. It was really easy to make.
Like Mist made in HyperCard or something like that? It was like very...
The originator of Mist, well, oh God, there was the...
or something.
There was the manhole, right? What was the name of that game? It was like you went underground. I think the original version of Mist maybe, but there were a lot of like puzzle games because you could get input and like, click where you wanted and have the cursor like change. But yeah, a lot of early games were HyperCard, and then it was just a really fast way to script stuff. So I loved it.
So in addition to the physical things that we're showing, we're also doing a little bit of jogs down memory road, and we have some footage from when some of these things were released. So here's a little clip from Computer Chronicles. I thought folks would enjoy this with the creator of HyperCard, and just also like a very interesting different time in computing. The idea of having a script on a button was like a big deal. So we're going to continue with Desk of Ladyada, but let's watch this video, see you on the other side.
HyperCard, what is it? It's not hyper, it's not even a card, it's not quite system software, it's not quite application software.
Could you tell us what HyperCard's all about, Bill?
Well, really simply put, HyperCard is a software erector set. It lets non-programmers put together interactive information.
Mm-hmm. Show us how you actually do this, Bill.
You use cards that contain graphics and text and buttons.
Mm-hmm.
Here I've got a stack of cards, and I can press on this button, and it will take me to another card.
Okay, and that button's particular function is get to the next card.
Right. You can have lots of buttons to do different things.
Okay.
Buttons can do things like dialing the phone and taking you to cards and lots of different
Whatever
things.
you tell it to do.
Yeah.
Okay.
The cards are grouped together into stacks that you put on a floppy disk and can share with somebody else.
Mm-hmm.
And you can organize it so that any card can jump to any other card.
Is this where you get that notion of hypertext built into the HyperCard system?
Yeah, it's kind of the freedom to organize the information according to how things are associated with each other, not just according to the next card in the list.
Right, okay.
The buttons, as I said, can do lots of things. Here's one that makes a noise and sounds. And you can have lots of different kinds of cards. The standard 3x5 card is a little weak metaphor, but you can include things like an expense report, or maybe a appointment book, things like that. Lots of different kinds of things can be on cards. Even little interactions. Here's a little keyboard that you could click on, and it makes sounds and moves the note accordingly.
So you can do things within a card itself. A card is just not some information.
What's real important is that cards contain both information and interaction.
Right.
Okay, and so, you know, we're not done with all the retro stuff. We've been working on some interesting things. There's a lot of computing history out there, including some intersections between like pop culture and, you know, what was the first time something was distributed on a floppy when someone like Prince was doing something. So Prince changed Prince's name to the artist formerly known as Prince, and you had to get this new symbol. And so they sent out these to journalists and more, and we got one of these. We borrowed it from Anil Dash. Thank you so much, Anil. And we put it on archive.org. Let me go to the computer real quick.
Yeah.
Here's where it is.
Yes.
You can go to archive.org/details/Prince_floppy.
Yeah.
And you can you can see a gatekeepery comment. So by the way,
Let's ignore that.
so by the way, there's a lot of people that do retro and archivy stuff that do not want people like Lamore or me or our company or our team doing anything around it. So ignore crummy things like that. So anyways, we put up the files,
Yeah.
and now I want to give a gift to Anil because this is a piece of history. And you know, the more you use that floppy, the more you access, eventually it's going to deteriorate. But this is a digital version of that.
Yes, and it's purple. The original was actually yellow, but you know, for Anil, because purple was Prince's color. And it's just the Pi Portal project that Anne and Noe and Pedro worked on. Except instead of displaying icons, we just put the image loader demo. It's like a 4-line Python script that just displays that image that was on the Prince floppy. We converted from a TIFF to a bitmap, and now just displaying it on the top of the floppy display. And then you can put whatever images you want, or of course program it to display your custom Mac icons. Or actually now we have GIF.io support. You can put your favorite animated GIF of Prince on there. So I think Anil's going to really like this. We'll catch up with him shortly here in New York City and hand this off.
Yeah, I want to make sure it's okay to give this gift. So do you want this or should I give it to someone else?
Okay.
Okay.
All right, cool.
So what's actually on your desk this week in addition to this?
Okay, so physically on my, I like how this is physically on my desk. Let me unplug this.
What's on the physical desk?
Okay, so we got our feather bones boards in. I know people were looking forward to those. The first one we got is this DVI feather. So let's go to the overhead and I'll show this off. So you've got the RP2040 and the buttons, battery charger, power supply, USB-C for programming and upload, 8 megabytes of flash. You get a STEM QT port over there. And then on that bones area, the empty space, is a big chunky DVI output connector that can connect to, you see, HDMI displays. And it works. So let's see. Of course, I'm going to do a live demo, which is always a little risky, but let's see if this works. So... oh, you know what? I think I accidentally misprogrammed this. So let me unplug everything else. Hold on. Live demo. Oh, actually, you know, let's go to the computer because I'll show off the DVI code. So, open, reset, 16-bit, hello. So this is the example we've got in the Pico DVI library. Let me just select the board. And this example basically makes the DVI output, it kind of like does all the work for you. Phil B did this, Paint Your Dragon, so that you just treat it like an Adafruit GFX frame buffer of 320 by 240, or because I have this 5-inch display that's that's 800 by 480, it's 400 by 240 P60. And that's because we pixel double. Like if you count the number of pixels you need to do 640 by 480, we literally don't have enough RAM. So what we do is 320 by 240 doubled. And the only thing you have to do is slow down the QSPI flash, because it gets overclocked so much it runs out of, it can't keep up with it and it hard faults. So let me upload this to the Feather. And I just have the example demo that's running on that we have for GFX that Philby also redid, where it like draws text and it has some charts, and it has line drawing. And one of the interesting things is normally for Adafruit GFX we're connecting to an SPI display, and so like you have to send that data over SPI. When you're using with HDMI, it's like instant because the frame buffer is immediately written out over DVI on that second core. So let's go to the overhead and we can show this off. Okay, so now I've got the demo running. So this is our
I'll ask an engineer. I pumped out the video because it's HDMI, and I'll show it like what the video output is. But you can look at it on the screen right now.
Yes, this is an 800 by 480 HDMI display. And so when you get in a moment, we're going to get to the, it's doing the rotation. So that's why it's going fast. So we'll rotate this. It goes through all the demo and then it rotates everything. So when you get to the speed up text, it actually, when we added like a frame per second to show, it's like, it's nearly instantaneous. Like it's so fast because the moment it writes to memory, it's immediately output. There's no blocking. So this can be kind of interesting. Like, basically we could have sensor data come in from the I2C and then immediately displayed. It could have video games, like it could do animation.
Visualizations.
Yeah.
This is going to be great because everyone has a large black rectangle in their homes. It does nothing. They can't program what's on it. Not really. There's all sorts of weird things that you could do with this canvas.
Yeah.
And now you could do it with CircuitPython.
Yep.
This is cool. This is gonna be great.
Yeah, and you can do like a mini computer where you you type and then it displays on the monitor. So the DVI output, and then we have the util and C and CEC pins, like in case you want them for something. HPD is hot plug detect. So this pin goes high when something's plugged in, so you can like connect that to something, because the 8 GPIOs are all used for the DVI output. But it works great. Paint Your Dragon did a great job getting all the code ready for me. I just plugged it in and ran the demo, and it just magically worked. So you see, this just needs a little bit of silkscreen love, and we're going to order this. So the first Bones board was a success, which is great because I know people wanted to get these files. So as soon as the PCBs are in, the silkscreen is done, we'll publish the files. And then for folks who want to use the Bones board and like change it around to do whatever they want on that space, just delete the DVI connector, and then you can put whatever you like in this spot over here. So first Bones board is done, very successful. So the next Bones board that we got in, and I'm going to just take this away and I'll lead into the great search, is I've got the RFM69 Bones board. So this, I just haven't hooked it up with an OLED. So it's kind of nice to have a STEMMA QT port because like I wanted to do the OLED demo. I didn't have to solder the feather wing. I just like plugged it right in. So this is an RFM69, but it's pin compatible with the standard like LoRa RFM9X 9596. And I've got a couple antenna options here. So first one is, I just put a through-hole pad so you can have a wire, 13-inch long wire. This isn't 13 inches, but it's kind of close. Good enough. And then also a UFL connector. And then we had a little bit of a spot for a vertical, not horizontal. I couldn't fit a horizontal STEMMA QT. But everything works really great. And all the extra I/O pads that are on the RFM connector go into the RP2040. So let me autofocus this. And then let me find the other one. One second. It fell on the ground. Pick that up. So we have 2 because you always have to test with 2, and then let me kind of see if I can get both of these into the screen. So when I press the boot button, which is also a GPIO, you can see on the right hand side it's like, yes, I got a message and it displays the RSSI, and then likewise if I press this button over here, there's basically sending one button press back and forth. That's it. Very simple. And just testing, that the antenna is working. And one of the nice things I like is that because I had a little bit more space, I was like really crammed everything in. I was able to fit that UFL. And on the previous desk of Ladyada, previous Great Search, we talked about UFL connectors and how to find them on digikey.com. So this week I'm going to show, if you're going to use this low cost style, just, connect a piece of wire. Quarter wave whip works really well for many, many projects. Inexpensive, easy. But let's say you want to connect this
Do
to
you
an.
want me to roll into the great search with the intro stuff and everything?
Just went almost. I'm
Okay,
I'm getting everybody excited.
You're winding up.
I'm winding up.
excited. I want to click the button.
I know you want to click fun. It's you have one of these boards, then you want to connect it to a panel mount antenna, like a really large antenna like this one, which looks like a magic wand, but it's not. It's an antenna. It's just really huge. You're gonna need a UFL to SMA adapter, and that's this week's great search. So let's now.
Where in the world is that part I need? The great search with DigiKey.
The highly anticipated Great Search, brought to you every single week by DigiKey and Adafruit. It's so exciting, even sitting here. I knew it was going to happen. I have a full seat, but I only need the edge. Okay, so what is this week's Great Search where Ladyada helps you find all the things you need on digikey.com?
Okay, well, let's go to the overhead, and I'm going to re-intro this and then get right to it. So on this design for a 900 megahertz radio module, we have a low-cost antenna option where you just solder a piece of wire. We have these spring antennas that they're like a couple cents. You solder them into a through-hole port, but let's say you want a really big antenna, like you want something panel mounted that you can connect to the outside of a box. It can be, waterproof then, and then just the antenna sticking out. For these, you'll want to connect an SMA and antenna. That's the most common, 400 to 800, 900 megahertz antennas. Almost all use SMA for the connector. They look like this, and you need something that takes this and lets you plug it into this micro UFL. Now, you might wonder, well, why not just have an SMA connector on your boards? You can. People definitely do. I have dev boards that have an SMA connector on them. You can plug the antenna directly in. But that sort of means, first off, you need a lot more space. They have to be hand soldered or wave soldered. They're physically large. They can't be pick and placed, whereas UFL can. The trade-off is, if you use UFL, they're a little delicate. They only are really meant for about 10 to 50 plugs and unplugs. So you do have to be careful with them because they're so tiny and delicate. They are good for up to 6 gigahertz, but you need to have this adapter. You need to have a little adapter cable that'll take you from UFL to SMA. One thing I want to mention, because this has tripped everybody up so many times I've seen. So you see how this has a little slot in the middle? There's a hole. And this antenna here, this huge antenna here, has the little pokey part. So the pokey part has to go in and matches up with the whole part. This screws in, the outside is ground, it makes a nice solid connection. The RF signals actually goes through the center bit, the little coaxial bit. But if you are doing 2.4 gigahertz Wi-Fi or BLE or Zigbee or anything that uses 2.4 gigahertz, the antennas are RPSMA, reverse polarity, which means if you notice, there's a hole there. So if you plug this into an SMA, notice that there's nothing it won't connect through. And you'll be like, my antenna's broken, my SMA adapter's broken, my board's broken, my radio signal's really bad. You need a different one called an RPSMA. I'll probably be able to show you that they have UFL to RPSMA, reverse polarity. So just watch out. 2.4 gigahertz and only 2.4 gigahertz, maybe 5 gigahertz also these days, because 5 gigahertz is used for Wi-Fi. They'll have RPSMA connections. See, hole in the middle. Whereas what we're going to talk about is 900 megahertz, which is SMA, which has the pokey part on the antenna, not the adapter. I don't want to talk about days that I've lost being like, what's wrong with my design? Until I finally realized opening it up, I'm like, oh my God, it's not connected through because I had 2.4 gigahertz with the wrong connector. Okay. Everyone's bumped into this, so I'm going to try to save you some time. So what we want is a little cable that takes UFL here, and this is the UFL connector. And again, on an earlier great search, we covered the UFL connector. It's pick and place. They're almost completely universal. Basically, if it's not SMA, it's almost always UFL. It plugs in like this, and it actually has a little bit of rotation. So just be aware of that. If you need to, you can mechanically stabilize this, but you know, it can rotate a little bit. And then this part you'll notice is bulkhead panel mountable. So you can unscrew this and you have a very wide panel mount that you can connect to. You've got some locking nuts as well, and then a nice plated hex nut, and you know, you screw it in, you attach it, then you have, make sure you have plenty of thread for your not RPSMA or SMA. You can then plug this in to make a nice solid connection. You'll note, I mean, maybe if we have time, we'll show it, but basically the dB RSSI goes to like, you know, -20 instead of -60. Okay, so let's go to
Go back to the computer.
Let's go to the computer. We're finally ready. Okay, so what we're looking for, and again, there's SMA and RPSMA. I don't want to talk about how many times I messed that up. But also UFL, there's WFL. And sometimes it's like UFL2 or UFL3. There's a lot of different versions. So just be aware. You might want to check data sheets, use your calipers to make sure what you're looking at is the right width of what you think it is. So UFL, it's Hiroshi is the original makers of the parts, or maybe it's pronounced Hyros. Hiroshi is the original maker of the UFL, but it's now universal. You'll see it everywhere. UFL to SMA. And so you can get the individual connectors. Also, you can get these adapters. So just to show the difference between the cables and the adapters, here's where you would go if by chance you have to connect an RPSMA thing to an SMA thing. You have to, like, you know, switch which side is the pokey part and which is the plug and which is the socket. You can get adapters that do the changeover for you. So that's available, but let's just try to get the right thing the first time. So coaxial cable. So first off, let's get active only, and then let's make sure, I mean, in my case, we're happen to be using 900 megahertz, but you know, let's just make sure we can do at least 2.4 gigahertz. And then in stock, let's apply. Okay. So we're going to have at the end free mount, sorry, panel mount, not free hanging. Free hanging would mean, you know, maybe it's an adapter and then goes to another cable or something, but we want what I showed you where it has the screw, you know, goes through the panel and you hex mount it on. So panel mount. And then you can check different lengths, you know, they go up basically from 2 inches, which is a little bit too short, and 3 inches to maybe you know, 19 or 17 or so. So let's do that. Let's just make sure it's a little longer than 2. So UFL, sometimes called UMCC, note that they do have RPSMA, which we don't want. We want SMA. And then, and also sometimes they have right angle or not, but, and you can see there's like tons of these. Apply all. You know, and then it's just a matter of like, you know, there's different makers, different lengths. You know, honestly, this one looks like pretty good, and it's only, you know, $3. Sometimes I look at, you know, what they have the most in stock of. Amphenol, you know, they make a version. You can see here, it's got, you know, the right UFL connector. This one from Tau Glass is good too. TE. They're all good. I mean, all of them are going to do what you want. They just have sometimes different cabling, different highest frequency. This one comes with an O-ring. You know, this one from Tau Glass is perfectly fine. So I'd say, you know, you want just a short cable. Goes down to a couple bucks a piece when you get them in quantity. This one is a good option. I'm going to pick some of these up, and then, you know, then you can just attach whatever antenna you want on the other side. Maybe next Great Search will search for a nice LoRa antenna to pair with this feather.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
All right. Well, between financial collapse and the Oscars, we got to bounce pretty fast tonight. So we'll answer some questions in the Discord chat if we didn't get to it while we were talking. Lots going on here, including Baby. So we'll see everybody next week. We got a full week of shows and more. Stay safe, be good to one another, and never let someone make you feel bad about the things that you love to do. So,
And always check for RP SMA versus SMA on your antennas.
two life lessons.
Two life lessons.
See everybody next week.